So we're back with conics, and I just finished talking about circles, and now we're gonna move on to ellipse. But by the end of all my videos, if you watch all of them conics, you're gonna be able to identify which one is which without anyone telling you, because you just have to understand the structure of the conics. It's like you see ellipse and hyperbola, they only equal to one, and it always equals to one. And you'll notice a circle, it always equals to the radius squared. So there are certain structures you'll realize that where you can identify which conic is what. But this one we're going to work with is going to be an ellipse, and I'll teach you how to find the foci and the relationship between foci and the major axis and the minor axis, and how to tell which one is which. Okay. Um, Again, we're going to put in this format. This is probably as hard as a problem you're going to get for ellipse, in terms of solving it. So we have 5x squared plus 3y squared minus 20x plus 36y plus 113 equals 0. Generally, when I solve for any conic, I like to put it into this format so you can easily identify, what the behavior and what the graph will look like. So let's start by, let's move 113 over so I can start completing the square. Let me subtract 113. Okay. And let's start factoring out the x's and the y's. Okay, so 5, 4, 20, 3, 12, 36. Okay. And now we gotta complete the square. So we take what, half of the b value, and I'm gonna go over in a completing a square video all by itself. You don't know how to complete the square. They should teach you how to do this before you get to the conics. So half of 4 is 2. 2 squared is 4. So we're gonna complete 4 into here. Half of 12 is 6. 6 squared is 36. Okay, so I got to add some kind of value. Since I'll add this on the left side, I got to add on the right side. So I have to add, let's see, 4 times 5, 20. I have to add 20. Plus, I also have to add, let's see, 3 times 36 is 108. Okay, so let's factor all these equations. So I'm putting in a format I can recognize better. Okay, x minus 4x plus 4 is x minus 2 squared plus 3 times x, that is just y plus x squared, equals to this. Well, that's, let's see, 128 minus 113, which is 15, I believe. Okay. And then to put in this format, you see there's a 15 here. Let's divide everything by 15 so I can make it a 1. Okay. And you'll see all the numbers will come in probably nice and even. So this will become x minus 2 squared over 3 plus y plus 6 squared over 5 equals to 1. You can see right away, the first thing you notice is the same format as the ellipse. You can tell something squared plus something squared here. You can see that it's different here. There's a different length. You see, if these two are the same, then it'll be a circle. Have you noticed that? Okay. Since the ellipse has different x and y axis distance. So now what we can figure out right now is that what's the center of the ellipse? Well, that's always hk, right? So it'll be 2, negative 6. Right? 2 minus 2 is 0. Negative 6 plus 6 is 0. So that's the center. Okay. The only thing that you need to do also is you need to find a focus, which is really the foci, because you have two foci and two focus, which is the foci in an ellipse. So to find a focus, usually it's c squared equals to a squared minus b squared. The way I remember this is more really like this. So what I usually end up doing is I just take the big number squared minus the small number squared equals to this. So it's the easy way to remember it. So in this case, the way what I do is it'll be 5 minus 3. Because this is really b squared, right? This is really, you can rewrite this as root 5 squared or root 3 squared, right? They're the same thing, right? So 5 minus 3 equals c squared. C will equal to will equal to radical 2, right? So the focus distance will be radical 2. I'll explain what the whole relevance of foci is. I think most people, when they solve for foci, they don't understand what the whole relationship is. Why do you need to solve for this? Are they just trying to torture us? So let me graph this and I'll show you the whole magic of this. So let's do center 2, negative 6. 1, 2, 3, 4, 5, 6, I think is around here. So that's the center. So how do you graph this? Well, let's see. Well, the distance for the x, see, this is how I figure out how wide this is, this distance, and there's how long it is. It's radical 3. Radical 3 is about, I would say, 1.7, okay? So it's going to be around here, from 2, and it's going to be around here, okay? So roughly is about 2 plus radical 3 or 2 minus radical 3 is this distance, okay? But radical 3 is about 1.7, so I'm kind of estimating where that is, okay? And the long distance, the y distance, okay, will be radical 5. Radical 5 is about 2.3, I think, off my head. So I will go up 2.3, about here, and 2.3 down, I will say it's about here, okay? So we're going to draw an ellipse now. And there's an ellipse, okay? And then you'll also have to find out the foci distance, which is radical 2. Well, radical 2 is about 1.4, so I will go up about here. Here's the focus. And down here, about 1.4, I would say about here. Okay? So let me put an arrow here. Here's the focus. Focus. Okay? They're both a focus. They have the coordinates. Let's see. This will be, well, since the center is 2, negative 6, and it's always, the focus is always on the major axis, okay? This is considered the major axis, which is the longer part of the ellipse, is considered the major axis. The shorter part of the ellipse, this part is always considered the minor axis. So that's how the terminology works. So the focus for the coordinates would be, let's see, 2. 2 doesn't move, it's still on the x-axis. So it will be 2, comma, let's see, negative 6. And you what? Subtract, well actually you add first, root 2. Let me rewrite this. Okay? And this will be what? 2, comma, negative 6 minus root 2. Right? That's this focus distance right here. Okay? And this, of course, is the center. Okay? So this is the center. This is the two focuses. Okay? And what's the whole relevance of foci and focus, like for ellipse? Like, why do you need them? What's the whole relevance of them? Well, the definition of ellipse really is that from the focus, the two foci, to any one point on the ellipse is always a constant, the distance. So that means this distance plus this distance, anywhere all the points around the ellipse is always the same thing. It doesn't change. So that's the whole relevance of foci in an ellipse. So this distance here, if you add them together, is the same. Let's say I go from here to here. That distance is the same. So that's the whole relevance of learning foci for an ellipse. So that's all there is. And again, this is the major axis. The major axis is always the longest part of the ellipse. Okay, minor axis is always the shortest part of the ellipse. So I hope that answers all your questions. Right now I'm going to move over to parabola, which is I think the same difficulty level as ellipse, and then we're going to move on to hyperbola, which is the craziest of all the conics in my opinion.